Hello and welcome to this lesson about polynomial operations. The learning target for this video is adding, subtracting, and multiplying polynomials. You may notice that division is not listed in this order or in these operations. You can divide polynomials, but that's fairly complex and that's a conversation for a different time. Right now we're going to focus on adding, subtracting, and multiplying. So when it comes to adding and subtracting, the big thing is making sure that we have like terms. And in case you don't remember what like terms are, it is terms with the same variables with the same exponents. At that point in time, you're just combining them. Okay? So let's do a couple of examples. Let's say we have something like 2x plus 5 plus 7x minus 6. So we're looking for like terms. We've probably already done this at this point in time in the year. So we're looking at something like 2x and 7x, and now we're just asking, how many of these do I have? I have 2, I'm adding 7. I'm going to have 9 of them now. Then I take a look at 5 and negative 6. I work on combining those. That will give me negative 1. Kicking it up a notch, we could have something like 3x squared minus 6x plus 10x minus 5x squared. Now here we have a bunch of x's. However, our definition of like terms says that they have to have the same exponents as well. So the 3x squared and the negative 5x squared are like terms. The negative 6x and the 10 are like terms. And they're the only ones that can interact with each other in these little groupings and pairings. So same idea. I have 3 of something, and then there's negative 5 of them. I combine them. I end up getting negative 2x squared. And then I have negative 6x and 10x for positive 4x. And then that's it. We've simplified it as far as it can go. These are not like terms of the x squared and the x, so I can't go any further. Now, to make things even a little more complicated, you may get like trinomials. So let's say we had something, sometimes they're given in parentheses, which makes it kind of nice. Let's say we have 5x squared plus 2x minus 4 minus 3x squared minus 6x plus 4. Now, we have to be careful with this minus sign right here. We need to distribute it to all of these terms. And so I'll rewrite everything. 5x squared plus 2x minus 4. Now, minus 3x squared plus 6x minus 4. That's the trick. Make sure that you distribute the negative sign to all of them. Now, if it's a plus sign, hypothetically speaking, we just leave it as 3x squared minus 6x plus 4, and we combine like terms. But the way it's going to be more complicated is if it is a negative sign and you have to distribute. Now, back to the negative one, or the subtraction one, where we've distributed. Find those like terms. 5x squared, 3x squared for 2x squared. 2x plus 6x is now going to be 8x. Minus 4 minus 8 are like terms, cannot combine any further, so we box it, we walk away. And so that's adding and subtracting in a nutshell. It's all about identifying like terms and then combining them. Now multiplying can get a little more complicated. First of all, let's start off with just monomials. The way monomials work is that you'll go with numbers and numbers and variables and variables. So let's say we have something like 4x to the third times negative 3x to the fifth. Well, here I'm going to take my numbers, multiply those together. That'll give me negative 12. And then I'm going to take the variables and work with those as well. So I'll have x to the third times x to the fifth. Here we need to apply our rules of exponents. And if that's the case, I will get x to the 8th. So you add the two exponents together, and there it is. Easy enough. Okay? Just watch out for negatives or anything else like that. In fact, let's just do another example. Let's say we have 2xy cubed and we're going to multiply that by 6x to the fourth y squared. Again, we go number to number, x to x, y to y. 2 times 6, 12. X times x to the fourth would be x to the fifth. Y to the third times y squared is y to the fifth. Box it, walk away. Now, where it's going to get a little more complicated is if we have a monomial and a binomial together. And what we'll just be doing is if we have a monomial times a binomial, or anything else, you're going to end up using the distributive property. Not property. There you go. Okay, so let's say we have something like 5x times x plus 8. We're just going to distribute the 5x to those two terms. At the beginning, I'm going to recommend you take your time. 5 times x, or 5x times x plus 5x times 8. That way you can actually see this and how it's all working, how we're making two multiplication problems. Then you can bring it together to get 5x squared plus 40x, because you're doing the same thing. Multiplying the numbers together and you're multiplying the variables together. Let's do another example. This time, let's go with negative 3x squared times 2x squared minus 5x plus 7. Same thing. I'm going to apply the distributive property to all three of these. And again, I recommend just take your time, write that extra step. It's not going to hurt anyone if you do that. Minus 3x, let's go minus 5x times 3x squared, and then plus 7 times negative 3x squared. And then just for consistency's sake, I'll write this in the other order as well. So I'll take the 2x squared times negative 3x squared. All right, now I can just multiply the numbers and the variables together to get negative 6x to the fourth minus 15x to the third minus 21x squared. There we go. Box it, walk away. So you're using rules of exponents and you're multiplying numbers. Now, where it gets a little more complicated is a process that we use that's called foiling. And so this is where we have a binomial times a binomial. And I said the word FOIL, or foiling, because it is an acronym. F stands for first. We have outside, inside, last. All right, let me show you how it works. Let's say we have x plus 4 times x plus 6. Now this is where it's going to get a little more complicated, and it's definitely going to take time. What you're really doing here is a double distribution, and this acronym helps guide you through it. X times x is x squared. Then you do the outside term, so that would be this x and that 6. X times 6 is 6x. Now we do the inside terms, which would be these two right here, and so that would be plus 4 times x, which is 4x. And finally we do the last terms, which would be 4 times 6, which is 24. Now usually you have one more step, which is to combine the two middle terms, because they're usually like terms, and you'll go x squared plus 10x plus 24. And that's the final answer. I'll do another example. Actually, I'll do two more examples, because I get that this is different. All right, now let's mix it up. Let's go x minus 5 times x plus 1. Again, we're going to use the FOIL process. So that's first x times x, which is x squared. Outside, which is going to be x times 1, so that would be just plus x. Inside, negative 5 times x, which would be minus 5x. And last, which would be negative 5 and 1, multiply those together to get negative 5. Combine our like terms, which are in the middle. That is x squared minus 4x minus 5. We box it, walk away. Finally, let's do it where we have something that's not just x at the beginning. Let's have 2x plus 3 times the quantity x minus 6. the process remains the same. The numbers are just going to be a little more complicated. So 2x times x is 2x squared. Then we go outside. That's going to be 2x times negative 6, which is negative 12x. 3 times x is going to be 3x. And then the last terms are going to be negative 18. 3 times negative 6. Again, combine the two middle terms. 2x squared minus 9x minus 18. Box it, walk away. And that is how we end up doing that one. So, foiling, I'm not expecting you to have watched these three problems and get it. Okay, it's a new concept. We're definitely doing new material here. So something we'll practice a lot more. But just remember that FOIL is for when we're doing a binomial times a binomial, and it is step-by-step instructions. First, outside, inside, last. Good luck with your homework or practice, and let me know if you have any questions.